Hi, I am IT PhD and today I'll tell you how to represent negative numbers in binary system. So there are three different ways to doing so, and they all based at the same idea of signed bit. So what does it mean, signed bit? Actually, in computer science, most of the time you use 8-bit numbers. So let's draw it. So we have 1, 2, 3, 4. 1, 2, 3, 4. And this is kind of 8-bit box. So we could put here 8 numbers. The thing is that if we want to write just positive number, for example, we want to write 2. So we write it like this. It will be 0, 0, 0, 0, 0, 0. And here we have kind of bit which represent that this is 2 number. But what if we want to write negative? In most simple way, and which is still used, but not in the computer architecture, so it's used most of the time just for educational purposes. It's sign magnitude. So what's sign magnitude? We just take one most significant bit. Most significant, it means that it's the bit which is on the right. So on the right of our binary number, it's most significant bit, MSB. So this most significant bit, it's represent sign. And if it's a 0, it's positive number. So this number positive right now. It means 2. But if this bit, it will be not positive, but not 0 but 1, then this number have a sign, and then this number will be not 2 but -2. So it's sign magnitude. It's not used in real like computers or like iPhones. So it's just the way to represent it, to explain stuff. Yeah. And if we take a look at the table which I prepared for you, so here we see that in sign magnitude we have such way of writing numbers. So example, so 0, it's just simple 0. This is all stuff here. It's signed number, so they have signed bit empty. It's 0. And other stuff, it's just regular binary. It's 1, it's 2, it's 3, it's 4. I explained in my past video how to read this stuff. But for negative stuff, we just add here sign bit and basically repeat this system. So we take unsigned way to write values and just add one most significant bit, become 1 for negative values. So for example, if we would want to write some bigger number, for example, if we want to have 8-bit, let's write like 8-bit, we use 8-bit, and we wanna write very big number. So let it be, so we create our box here with 8 placeholders, and we want to have negative number. So what we will do, first of all, we add sign bit. So this is sign bit. Beautiful. Then we want to write the biggest possible number for 8-bit negative number. So it will be, if we would put all this stuff, will be ones. As you might remember that how to count very fast such stuff, so you could just write base 1, 2, 4, 8, 16, 32, 64, 128. So as this bit its signed bit, we do not count it, so we do not have here 128, but all other stuff we have here. And easy way to calculate this number now, it's just take this maximum value, which is 128, and make it -1. Then it will be kinda minus 127. So this number in negative way, it represents -127. Let's make now this, let's take this number as a positive number. If we say that it's positive, it's simply, we do not think that this sign, it's our sign bit. We just say, okay, this sign, it's regular sign, and then we have 129, and next bit will be kinda 256. And as I showed you this trick, so 256 minus 1, it will be 255. So this thing here, it's actually for us could represent different things. So if we would look at this number as unsigned, it will be 255. But if we take this kind of piece of memory inside of our PC and we look at this box, this variable as signed variable, it will be minus 127. Yeah, and it's signed magnitude. So it's first way to like write it. The thing is that you might notice that we have, if we use such way to represent numbers, we have 2 zeros. So this 0, yeah, it's better to go this way. So we have this 0 and this 0. It's 2 zeros, which is quite confusing, and it means that it's not really effective because 0 can't be negative. So it's not really fun. This system, it has already has some problems because we do not want to have not effective system. Another problem is then it's if we just calculate stuff, like we make some operations like plus, minus, it's also not effective. Yeah. So what people thought, they get a new system which called ones complement. And ones complement system, what does it mean? It means that if we take number, for example, again, let's take number 2. So it's unsigned number 2. And if, example, in your computer, in some old computers, this system, it was really popular. Right now, it's not used also. What's now used, I'll tell a bit later. So ones complement, what basically, we take these numbers, we also add sign bit. So actually, all these three systems, they use sign bit. Yeah. And all other bits, we just, what we do, we kind of reverse it. So if we have here 0, it becomes 1. If we have 1, it becomes 0. If we have 0, it becomes 1. So one complement system, we take our regular unsigned way to write number and then reverse it bit. Let's take some big number, again, like 8-bit number. 1, 2, 3. So what does it mean? Again, 1, 2, 4, 8, 16, 32. So this is 32. Now, if in some old computers, if you like go back 30 years before now, how people stored negative numbers then? They use this system, and this system, it's kind of you make this reverse stuff. So you make 0, you make 1 once, and once become 0. This way. So it's basically you just invert all this stuff. And this system, it was for real, it was used. People used this in the past. And if you take a look now how it's work, you see here that we have again 2 zeros, yeah, which is also not really effective. But anyway, still this system, it was better than previous one because it gave possibility for better calculations. So yeah, you just invert all the numbers. And here we see that each number also has sign bit. So as in our first system we had everywhere we have signed bit, and in one's complement system with also for negative numbers, so they all have signed bit. So the current system, which is used in all like personal computers almost, and in all like iPhones, everywhere, it's called two complement. And two complement system, how it works. So you basically make one complement. For example, you have number like let's write another big number, another 32 we will write, yeah. And first of all we want to make first complement. To make first complement you just invert all the numbers, so it's like it's become like this. So it's first complement, and then how to make two's complement, you just add 1. So to make two complement we should just add 1, that's it, to this number. And then if we would add 1, what we get here? We would get the same kind of number almost, but at the end we would have 1. So this one, and it's called two's complement. It's how negative numbers stored in real computers right now. All stuff which you use everywhere, it's how they used. And if you would see at this table, they also have everywhere signed bit. And as you might notice, this system, why it's appeared, because it gives us possibility to have 1 0. So you see we have this 1 0, but second 0 we just do not need it, yeah, because we just invert. To invert this 0, when we invert all zeros, we actually, let's make it. So we have our 0 number. If we would invert it, so make one complement, first complement, it's become it's become 1 1 1 1, yeah. So it's kind of 1 1 1 1, and people thought, it's quite stupid that we have 2 zeros. So we want to have 1 0, and so it will be like proper way. So they thought, what if we would just add 1 to this number? So if we would add 1 to this one's complement, first complement representation of negative 0, we would get basically we would get 0. You see? Yeah, because kind of if we would add 1 here, it will become this number. But this, for example, we have 4-bit character, yeah. But as we have 4-bit character, we kind of do not use this bit because we have only 4-bit here, and that's why we have proper 0. So actually, if we take a look at 1's complement, you will see that here this 0 which we have, this -1, where it's a blunder here. There is a blunder which very easy to fix. So if we would take this number and we'll add 1 to it, it's will become 0, 0, 0, 0. So it's what we need. So this second complement, it's basically it's doing this thing. So let's take a kind of bigger number now. So let we have not 4-bit, but we would have much more. We would have 8-bit. So we take our 8-bit number. Yeah, and we want to have a 0 number here. Let's make it with a bigger number. Yeah, we want, so our unsigned 0, it's this one. This one, it's our unsigned. So if we want to make signed 0, first we make first complement. So we make it everything once. So it's kinda first complement, and it's stupid. It's stupid because why 0? Why we have such stupid 0? Yeah. So because for our computer arithmetic inside of the memory of your computer, the best thing to have a 0 is to have actual 0. So it's what we want to have. We want to have zeros as a 0, not as ones. So people thought, okay, so let's make it +1, and then if you would make +1 to 8-bit character, then it overflow. So it will become. So it will be like this, another 8-bit with some overflow. So this is our 8 bits. Yeah, if we would make +1 to these 8 bits, what we would have? We would have number 1, and here we will have all zeros. So we have 9-bit character, but we can't store 9-bit character in 8-bit. So it's just go away. So with this +1, we get proper 0. That's why everyone right now using 2 complement system. I mean, in all like electronic devices, it's used everywhere because it gives us possibility to have real 0. Yeah, you see here. And because of we get rid of this fake 0, we could store additional negative number. You see? So as everything moves down, so here we had 0, -0, and etc. And here this value it's become available. So in 2's complement we use it not for the fake 0, we use it for -1, and then we could have one more number. That's why, for example, if you go for 8-bit number, if it's negative, if it's a unsigned value, it's from 0 to 255, but if signed, it's from 128 till 127. Yeah, see, it's 27 here, because here we do not have a fake bit, you see. But the most important critical reason why we like to complement, because of its kind of give you symmetry and makes calculation very fast. Why? So let's take 1 and -1 and make addition with them. So we take 1, and this is signed number. We look at this as a signed number, and we take -1, which is basically all ones. It's also signed number, and if it's signed number, what does it mean? It means that our first bit, it's signed bit, so it doesn't represent a number, and we can't kind of influence it. Yeah, so the thing is that if we would make, like, we take 1 plus minus 1, and we know that it should give us 0. Yeah, we know that it should be like this. So if we would make plus or 1 plus minus 1 here, what we would have? This bit, it will overflow our value. So because this stuff and this bit, what it will give us? The result will be 1, 0, 0, 0, 0. Why it's so? Yeah, because it's kind of how we make addition. And the thing is that, you see, this bit here, we do not store it, because right now we use like 4-bit values, and for 4-bit values we kind of do not store it, so we do not look at it even. And we have what we have left here. We have left 0. So the thing is that all these values, for example 2 and minus 2, they have symmetry. So if you make addition of them, you would have 0 as a result. That's why it's very fast to calculate, and that's why your computer or your mobile phone, they work so fast, because they kind of using this advantage. They can calculate these numbers very easy and very fast because of this symmetry, and the result will be always pure 0. It's especially easy to notice if you would take minus 8 here, yeah, so which is 1, 0, 0, 0, and you would take like 8. You see, we do not have it, but we know that 8 it's 1, 0, 0, 0. Yeah, but it's kind of, if it would be unsigned, so unsigned 8, it's this number. And the thing is that signed minus 8, it's kind of the same. So you see, it's just but yeah, of course, in real life, in your like computer, you can, but it's very bad thing to calculate signed and unsigned stuff. So you do not do it. But you just see this kind of similarity between them. You always, like, when you make calculation at your computer, you all values should be counted as signed or as unsigned. So you can't take signed value and add to it unsigned. You can do it, but you would have kind of wrong results. But it's just like a way how I wanted you to see that it's this symmetry we have it with this 2 complement. It gives us this new property of the number. Take a look at the overall table with all 3 ways. So we have here the most simplest way to add sign. Yeah, so we just add sign and write then regular unsigned value with a sign. So it's basically, we just take it's a 0, so we just take this stuff, so it's the same, but we add the sign bit. Then first complement, which was used in some very ancient arithmetic, so with some ancient ways to calculate stuff, like 50 years ago or even more. So this system used, and we just invert bits. So if we would want to have 1, to make it minus 1, we invert it, and 0 become 1 once, and 0 and ones become 0. Yeah, you see? So it's first complement. And we have 2 zeros because we have to invert stuff. So here we have 2 zeros because we just need to add sign bit. And here we have 2 zeros because we invert 1 0 to another -0. And modern system, which we use right now, it's this one. So here we have, and we take first complement and add 1 to it. That's it. Very simple, actually. So you add 1 to it, and this way you get rid from fake 0. So it's basic idea. And it gives ability to use very fast calculation. So when you have proper 0, and when you want to calculate negative numbers like make subtraction, addition, multiplication, with this second complement system, it's become very fast, much faster than with previous system. That's why they are not used right now. That's it. Thank you very much for watching. I hope this video will help you to understand these systems. Don't forget to subscribe to my channels. I'll make more videos about C programming and some other stuff. Have a good day. Hope to see your comments. Bye.